Welcome back, Pre-Calc. I hope you all are well. We are in 4.1b today. We're going to look at arc length and angular speed. First, I'm going to force a pause on your screen and make sure you've got everything on your checklist. Go ahead and hit continue when you're ready to go. All right, awesome. We are going to start with a warm-up. So I am going to actually force another pause on your screen here in just a moment. I would like for you to do something kind of similar to what we did yesterday and find the length of a whole circle with radius 4 units, and then find the length of just the top half and the length of the quarter of the circle. Okay, so I've got the answers on the screen for you. Hopefully you got 8 pi, 4 pi, and 2 pi. I wonder if you notice or if you wonder anything. So maybe you will notice that these are pretty similar to what we got the other day when we were looking at radian measure. If I want to find the angle measure in radians of the entire circle, that would be 2 pi, right? This piece here. And then if I want to find the whole circle, I can take that and multiply by the radius, okay? And this happened each time. Notice that if I want just the quarter of the circle right here, that's 90 degrees, but that is pi over 2 radians. And if I take pi over 2 and multiply by the length of the radius, I get 2 pi, what we got up here. Okay, so we're going to actually put that into a formula. So this is going to be our first formula for today. In your notes, can you write the words arc length for me? And the formula is going to go like this. It goes S equals R times theta, or S equals R theta, okay? Now let's put some labels on each of these. So let's start with R. What do you think R is? R is going to be my radius. What do you think theta will be? Theta is going to be my angle, but this is really important. It has to be in radians. Notice when we did that warm-up, we were looking at not 90 degrees, but pi over 2 radians, okay? So the angle has to be in radians, and then S is your arc length. Okay, so let's try an example. Write this in your notes for me. We've got a circle, and you can just put R equals 27 inches, and theta is 160 degrees, okay? So we can do R equals 27 inches, theta is 160 degrees, and we want to know the length of the arc intercepted by that central angle. So we're looking for what letter? We are looking for S, okay? Now, we cannot plug these straight into the formula Y, because theta is not in radians yet, right? But we know how to convert from degrees to radians, so let's go ahead and do that. Let's take 160 degrees. Let's see if this will pop up. All right, times, and to convert from degrees to radians, what do we want to multiply by? So we want to multiply by pi over 180. Okay, so this is going to give me 16 pi over 18, also known as 8 pi over 9, right? So now I can go ahead and plug into that formula on the top. So I've got S equals R theta. S is what I'm looking for. R was 27 inches times 8 pi over 9. The 9 and the 20 will reduce, right? So 3 times 8 is 24. So I'm getting 24 pi inches as my final answer. Awesome. Okay, now I'm going to force another pause on your screen, and I'm going to ask you to copy my screen. Okay, so we are going to look at 2 different kinds of speed today. We're going to look at linear speed, which is the type of speed we are probably more familiar with. So that's how fast you move forward, like in miles per hour or feet per second. So that is what we define as linear speed. So how fast is your car moving, for example. We're also going to look at angular speed. So this is how fast your angle changes. Okay, so that would be in degrees per minute, radians per second, revolutions per minute, okay? All right, so now I'm going to ask that you copy my screen again, and we are going to do a little experiment with 2 of my son's trucks here. So we've got what I'm going to call the big truck, which is Blaze, and the little truck. And we're going to look to see how is linear speed related to angular speed. And what we're going to be looking at is the kind of the circumference or the radius of the tires here, okay? So I'm going to force a pause on your screen, go ahead and copy my chart, and we're going to look at these trucks. Okay, so we are going to be looking at 4 videos, and what I would like for you to do is just fill in the top parts here, and then we'll fill in the bottom parts together. The first 2, we're going to keep the angular speed constant, okay? So then we're going to see which one has the faster linear speed. The second 2 videos, we're going to keep the linear speed constant and see which one has the faster angular speed, okay? So the first video we're going to watch is the big truck going at 1 revolution per second. All right, so here's the big truck. He's going to go 1 revolution per second, and we're going to go for 5 seconds. So then we want to see how far he ended. And I've got my measuring tape in inches there. So 1, 2 revolutions, 3, 4, 5 revolutions. And you can see he landed at, looks like 19 inches. So for that first row, go ahead and put 19 inches per 5 seconds, okay? And we'll get a calculator and calculate that in just a bit. So first one, 19 over 5. All right, now let's see how fast and how far this little truck goes, going 1 revolution every second as well. There's 1, 2, 3, 4, 5. Looks like he ended right at 7 inches. So he'll be at 7 inches per 5 seconds. So 7 over 5. And again, we'll calculate all these in just a bit. Okay, this time I'm going to keep the linear speed constant for the 2 trucks. Okay, so we really need to watch in that little gray dot right there and see how many revolutions it makes, okay? So we're going to see as soon as it goes all the way around, that dot goes all the way around, that'll be 1 revolution. Okay, so this time we're counting how many revolutions as opposed to how many inches. All right, so let's take a look here. So there's the dot, and we're going to go 1 inch per second. Oh, there's 1 revolution. So in 5 seconds, let me play this again. One revolution. So in 5 seconds, it looks like it went about, should we say 1.3? 1.3 revolutions in 5 seconds. Okay, so for that row, go ahead and put 1.3 over 5. All right, last one. Here we've got the little truck, and we are going to keep this again at a constant linear speed moving at 1 inch per second. So hopefully you're hearing that metronome every second. We're going to go 5 seconds. And again, we need to count how many revolutions the little truck makes in 5 seconds. So let's see here. I'm going to watch that little gray dot. There's 1 revolution, 2 revolutions, 3, and there it stopped. So I'm going to say about 3.3. We're watching it again here. 1, 2, 3, and just a bit more. So if you see that gray dot is right there. So let's do 3.3 over 5 for that last row. All right, so hopefully your table looks something like this. If it doesn't, you can always pause and fill it in. Now let's go ahead and just calculate these. So we've got 19 over 5, so that is going to be 3.8 inches per second. And then I had 7 over 5, which is going to be 1.4 inches per second. Okay, so let's think about that. When they had the same angular speed, the big truck went faster than the little truck in terms of linear speed, right? So why do you think that was? Yeah, that's because of the radius. Okay, now conversely, let's take a look at when we held the linear speed constant. We got 1.3 revolutions for 5 seconds for the big truck, which is 0.26 revolutions per second. However, for the little truck, we got 3.3 revolutions for 5 seconds, in other words, 0.66 revolutions per second. So you can see that holding the linear speed constant, I don't know what happened there. So holding the linear speed constant, the little truck has a faster angular speed than the big truck does. All right, so let's look at your last formula for today. Would you write this in your notes, please? V equals R, and that's the Greek letter omega. Okay, and let's put some labels to this. So V is going to be your angular speed. I'm so sorry. Is your linear speed, also known as your velocity as long as you are moving in the positive direction, okay? R, not surprisingly, is your radius, and omega is your angular speed. All right, and hopefully you can see some similarities between the formula we did earlier in the lesson, which was S equals R theta, okay? Also, hopefully you can kind of buy into this because you can see if you've got a constant angular speed, then the larger your radius, the larger your linear speed is going to be, right? So Blaze went faster than the little truck when they kept the same angular speed, right? Because Blaze had a larger radius. Okay, so let's try this problem together. It says a 15-inch diameter tire on a car makes 100 revolutions per minute. So first it says find the angular speed of the tire in radians per minute. Okay, so let's pause here. First of all, how many radians in a full rotation do we think? Remember, there's 2 pi radians in a full rotation. Okay, remember that when we were looking at S equals R theta, theta had to be in what? Do you remember? Theta had to be in radians. So similarly here, your angular speed has to be in radians per some unit of time, if we want to use this formula, okay? So part A is asking us to convert 100 revolutions per minute to radians per minute. Okay, so let's try that. So if I've got 100 revolutions per minute, and I would like to end in radians per minute, I really want the revolutions to cancel, right? So if I have revolutions in the numerator, now I need a revolution in the denominator. See if it'll pop up. There we go. And I want to end with radians, or rads in the numerator. Okay, so see how the revolutions are going to cancel now? So now let's fill that in. I've got, we said, 2 pi radians for every 1 revolution, right? So the revolutions will cancel, and it looks like I get 2 pi times 100, so 200 pi radians are left, as well as minutes in the denominator. Okay, then it says find the linear speed of the car in inches per minute. Okay, so now I'm good to go. I can use that V equals R omega because now I have my rads per unit of time, right? So let's plug that in. I've got V equals R times omega. V is what I'm looking for. That's my linear speed. What is R? So R is going to be 7.5 inches, right? And then omega is my 200 pi rads per minute. And if I multiply all that out, that's approximately 4,712.389. Always round to 3 decimal places unless directions say otherwise. And let's think about units. Let's see, 7.5 was in inches. My angular speed was in rads per minute. Rads is a unit multiplier, so I'm just left with inches per minute, which is what I wanted. So we are good there. All right, so let's do our last example. We can call this the merry-go-round example. So let's say you and your friend are on a merry-go-round. Your friend is 1 foot away from the center, and you're pushing the merry-go-round whose radius is 4 feet. You complete 15 revolutions every minute. How fast is your friend moving in feet per minute? And how fast are you moving in feet per minute? Okay, now just to clear things up, I am not talking about, let's see if it'll pop up. about the thing on the left. Okay, I'm not talking about a carousel. I'm talking about a merry-go-round, which are pretty much being removed from playgrounds now because apparently they're too dangerous. But we loved merry-go-rounds on the playground when we were little. So we are talking about perhaps that is maybe your friend, and that is you, and you're making the same angular speed, right? You're all going 15 revolutions every minute. However, who's going to have the faster linear speed? Let's take a look. All right, so you're both going 15 revolutions every minute. And remember, if I want to apply this formula, V equals R times omega, omega has to be in what? Omega has to be in rads per some unit of time. So let's work on that first. So I've got 15 revolutions every minute. I want to convert that to rad, so I need the revolutions to cancel. There are 2 pi radians in 1 revolution. So now these go away, and 15, it's delayed here. 15 times 2 pi is going to be 30 pi, and I'm left with rads over minutes, which is the units I want. I definitely want rads, and look here. I want my final answer to have a denominator of minutes anyway, so now I don't need to worry about the unit of time either. Okay, so the first part says, how fast is your friend moving? So my friend, if I plug this into V equals R times omega, well, my friend's radius is 1, and we have the same angular speed of 30 pi. So my friend is going 30 pi feet per minute, right? I'm going to force a pause on your screen, and I want you to see how fast you're moving. All right, so you should have gotten about 377 feet per minute, 120 pi to be exact. Answers on the screen, so you can take a look at that. All right, and that is all for today. Go ahead and get homework directions from your teacher, and we'll see you next time.